The next topic is electrolytes, and they are the substances that conduct electricity because of the mobile ions in the solutions. The more ions there are, the better conductor they will be, because more ions will be flowing around and then conduct the electricity. Strong electrolytes dissociate or ionize completely in solutions. So for example, there are strong acids and bases and soluble salts. There are 7 types of strong acids, and you should memorize all this for the test and also for the AP exam. And you have 8 types of strong bases. Non-electrolytes are the covalent molecules that do not conduct electricity, so they can be nonpolar molecules. Next topic is the solubility curves, and this shows the relationship between temperature and solubility. So for liquids and solids, as temperature increases, the solubility increases. But for gases, as temperature increases, the solubility decreases, and you might wonder why, but this is because as temperature increases, the gas molecules will move faster or even faster, so it will be hard to keep them under control and make them soluble in water and make them just stay in water in liquid state. And in gases, solubility increases with increasing molar mass. So if the molar mass is larger, the solubility of a gas will be larger because LDF increases, and the attractive forces from LDF will keep them in the liquid and make them soluble. Next is the relationship between pressure and solubility, and for liquids and solids, they are not affected by the pressure. Both gases are affected by pressure. As pressure increases, the solubility increases because it will be easier for us to keep the gas molecules in control when pressure is increased. Henry's law shows the solubility of a gas is directly proportional to the partial pressure. So this is the formula, and this is the solubility graph. So if you're above the solubility curve, you're supersaturated because you have more than the maximum amount of solutes that the solution can hold. If you're on the curve, you're saturated. You have the exact maximum amount of solutes. And if you're under the curve, you're unsaturated, which means that you can have more solutes than you have present. Next topic is the heating curves, and this is a very important concept in AP Chemistry, and you have to know this for the thermodynamics unit as well. So there are 3 types of equations that you have to know, and first is the Q equals MCAT that you might be already familiar with, and this is used for the curve that increases over time. So this is used when the molecules are having increasing temperature. And Q equals mH fuse and Q equals mH vap are used in the flat curves over here, this one and this one, when molecules are having the phase change. And transforming from one state to another shows a flat line, no change in temperature, because all the energy is used for rearranging the particles and used to stretch the IMFs to change the phase. H fuse is the energy required to transform 1 gram of solid to a liquid, and H vap is for the liquid to gas. They are both positive because energy is absorbed for the phase change. And we have a practice question here. You are finding the energy in kilojoules required to change 5 grams of ice at negative 10 degrees Celsius to 66 degrees Celsius. So you have to divide this into 3 steps because you are looking at these 3 lines in solid state, transforming state, solid to liquid, and then in liquid state. So for this first curve, you're using the equation of Q equals MCAT. So it equals 5 grams times 2.11 joules over grams degrees Celsius times the change in temperature, negative 10 to 0, so 10 degrees Celsius. Then you have to divide it by 1000 to convert it into kilojoules. And you'll get some number, and we'll just write A for that. And for the next step, or this next curve, you'll have to use the equation of Q equals mH fuse, because you're having a transformation, not the increase in temperature. So you're simply just multiplying the mass by the value of 333 joules times 1 kilojoules over 1000 joules, and then you'll get some value of B. And for the last step, for this step, you're also using the Q equals mcat, so you're doing the same thing, but you have to make sure that you know that C values differ from ice state at -10 degrees Celsius from the liquid water state. So for liquid water state, it will be 4.184 joules over grams per degree Celsius that you will be more familiar with. However, in ice, it will be 2.11 joules over grams per degree Celsius times the change in temperature, which is 66 degrees, times 1 kilojoule over 1000 joules, which you'll get some value of C. And then the Q value finally will be the sum of all these three, and you'll get some number. And the number you get will be in kilojoules. The last topic for today is the colligative properties, and they are the properties of solution that depend on the number of particles, not on the mass. So mass will not affect the colligative properties, but only the number of particles. First is the vapor pressure, which is very important. It is the pressure by particles escaping from a liquid. So you have a solution, and then it is the pressure by these liquid molecules escaping from the liquid and becoming a gas. And volatile substances can escape readily, but non-volatile solute molecules, if they are added, the solvent becomes less volatile and the vapor pressure will decrease because surface area possible for evaporation will decrease. So in the solution, if the solutes that are not soluble are added, the evaporation will decrease because these non-volatile substances will block the liquids from escaping the solution, which will decrease the vapor pressure. Next is the boiling point elevation. It's when a solution of a non-volatile solute boils at a higher temperature than pure solvent because vapor pressure is decreased in presence of a solute. If the non-volatile solutes are added, as I just said, vapor pressure will decrease. It will be harder for these liquids to become gas particles and boil because of this non-volatile solutes. Therefore, temperature has to be higher to make vapor pressure equal the atmospheric pressure, because in order for the liquid to become gas, the vapor pressure exerting on outside will have to equal the atmospheric pressure exerting on inside. Next is the freezing point depression. Heat must be removed to convert liquid to solid. If the solution is more disordered than the pure solvent, when the non-volatile solutes are added, so it will require even more heat taken away to make it ordered and to make it solid state. So as the non-volatile solvents get added, the solution will be more disordered and it will be even harder for you to make this into a very ordered state of solid. And the last topic is the osmotic pressure. Osmosis is the net movement of solvent from the area of higher solvent concentration to the area of lower solvent concentration. So if you have the two concentrations, the bridge that the solution can go through or the water can go through, and this is the area of higher solvent concentration, and this is the area of lower solvent concentration, the solvent or water will move from the higher concentration to the lower concentration. And water moves to equalize the concentration of both sides until pressure is too high. This is the end of the video, and thank you for watching.